Hello everyone, today I'm going to be going over a problem called Group Anagrams. Group Anagrams is a problem, so you're given an array of strings and you're supposed to group the anagrams together and you can return the answer in any order. So for example, if we have the word eat, this is an anagram for tea and also an anagram for 8. So what you want to do is you want to group these three words together into a group at the end. But the thing is, you won't just have these three words, you will have more words potentially. So tan, an anagram for nat, and these two words become a group, and you can have one more word, for example bat, and bat could be your final word, and it may or may not have any anagrams. And so I've nicely grouped them all together, but when you get them as an input string, they're all in a random order and you don't know if they are grouped together or not. So what you want to do is output them as a single array where there is a group of arrays inside that single array, each representing an anagram group. So you have bat, which has no other anagrams in this input, and then you have nat and tan, which are anagrams of each other from here, and then you have 8, eat, and tea, which are anagrams of each other. And so that's our input and output example. I'll show you a couple other examples. So you have over here an example where you just have an empty string, then you output an empty string, and then if there's just one letter or one string inside, then you output just that on its own, similar to how a bat is on its own over here. Okay, so that's how that works. And so let's think about how we can solve this problem. So let's look at the ending here. So we have 8, eat, and tea, right? So what if we take these three words, and if we are to think about how can we detect that these are the same, well, one way we could do this is think about the lexicographical order. And lexicographical is a fancy way of saying alphabetical. I say lexicographical because typically in these algorithmic questions or mathematics style questions, you will hear the word lexicographical. So I'm just trying to make you aware of that. So for example, you have the word 8. Let's think, how can we reorder this so it's alphabetical? So we have AET. We organize eat alphabetically, so we have AET, and finally T alphabetically, so A goes to the beginning, T goes to the end, and so we have AET again. So now when comparing these are exactly the same, so we know that these are all anagrams of each other. So what we can do is with these we can see, okay, well, let's create a hash map or a dictionary where we have AET as the key and the value being 1. So we have 1 AET now. We're going to take this other AET, we're going to store it in our dictionary, we increment our value in our dictionary, and we put our final AET. So we know that at the end, we have 3 AETs. And so we know that these are anagrams of each other, okay? But what we're not doing is actually outputting these three words. So we need to sort of think about how do we keep those words. So let's look at this whole list or array and see if we can figure out how we can store them. Okay, so let's start with the first one. We'll start with eat, right? So eat, we'll look at this word, and with eat, we'll say, let's organize this word down here alphabetically, so EAT, okay? And then we'll go ahead and we'll create a key for AET. But instead of using a value of an integer where we increment the number here, what we'll do is we'll take the word eat and we'll store that in our dictionary. So we're just going to be appending, so this type value is going to be a list. So we'll append at the key of AET the word eat, right? So we're always keeping this. And then T, we're going to go ahead, we're going to sort this alphabetically, and then because we see AETs already in our dictionary, we'll go ahead and we will take T and we'll store that in our dictionary. We'll append to our list. Okay, so we'll move on to tan, and then we'll go ahead and we'll go down to tan and organize that, and it's ant. Ant is not in our dictionary, so we're going to create an entry for our key value of ant, and then we'll go up to tan and store tan, appending it to our list over here. And then so we'll continue, we'll go down, and we'll say, let's take organize this AET, we have it in our dictionary, so we're going to append 8 to our dictionary over here. And then next we'll move on to nat, and nat will go down, sort it, we get ant. Ant again is in our dictionary, so we'll say ant. Let's go ahead and store nat in our hash map, appending it to our list, and then we'll move on to bat, and we will organize this ABT. It's not in our dictionary, so we'll store ABT, and so we'll append bat to our list in our dictionary for the key of ABT. So now at the end, all we have to do is take these three, and we can say, let's create a list where we output all of them, all these as separate groups for our output, and these are just the values of our dictionary. So you have key value, then you just output all the values which are down here. Well, what's the problem with the previous approach? Whilst yes, we have a space complexity of O and K, every time we're sorting a string, the sorting algorithm will have a complexity of n log n. So for example, we see eat, we need to sort that, that's n log n. And so same with t, that's n log n, sorting it to 8, right? So on and so forth. So this becomes m times n log n, because every single string here we now have to sort, and there we go, is m n log n, right? So this isn't the best time complexity, you know, we can do better. So is there a better way? Let's look at our data structure for how we're storing this. So yes, we are using a hash map, and when you're in doubt, people will say, use a hash map. Now, if we can use a different key for a hash map, that would be better, because that's where we're getting this n log n from our sorting. So is there a way we can better represent these groups, these anagrams, without having to sort? And so let's get rid of these, strike those out, and we'll take them off. Okay, why don't we use a way of counting each value, you may think, in this word, because there's one E, one A, and one T. So we have one E, one A, and one T, right? And the same for tan being TAN, one TAN, one NAT, and the same for bat, one BAT, right? So if you think about sets, set theory, a set is equal if the values in each of the sets are the same. And well, a hash map is basically a hash map is like a hash set, right? So you could represent it like this, and you can do a check to see if they're the same. Now, the problem here is that having a key of a hash map or a hash set is not possible. The hash set data structure itself is not hashable, so we cannot use a key of a hash map. So let's think about another way in which we can represent EAT having one of them. And so if we take our letters and we think about all the letters which are possible, we can represent it in a tuple or a list as letters A to Z, or lowercase, right? If we do have uppercase, all we have to do is convert it to lowercase. The reason why we want to have just one of each letter, not one uppercase, one lowercase, is because a lowercase and uppercase letter make no difference. In the case of an anagram, having a capital letter at the beginning does not make it not an anagram. For example, E with a capital here is still going to be an anagram of T with a lowercase, right? So we will represent each of our letters, and we'll count, for example, let's take a empty list or tuple, and in this case, I'm showing it as a tuple, but we will use a list at the beginning and then convert it to a tuple. So over here, we will have E, and we will say, okay, well, we have one E, we will change this value to 1. We have one A, we will change this value to 1. And we have one T, and we will change this value to 1. So all of these strings up here, they are correctly represented by this data structure, this tuple, right? And so we can do the same thing for tan and nat. So we can have T, we have one T over here, we have one A over here, and we have one N over here. And so one N, one A, one T is the same, right? So they both represent the same word, right? And say, for example, you had double T, so then you just increment this to be T2, right? So that's why we're using an integer over here for our tuple. Okay, and finally bat. So we have one B, we have one A, and we have one T. Okay, so that's our representation of bats. Okay, and so now we have our keys, and there are in tuple representation. So all of these words this tuple represents. So these words are represented by this tuple, and bat is represented by this tuple. So for each word, we're going to construct a tuple. So we'll iterate through each word. We'll construct a tuple for each. So each letter in the word, now we're reducing it. So now instead of having for each word, so m for each word, we will sort, so n log n times m. Now we're just going to be doing m, so the number of words, times n, so the length of each word. So that's a much better way of finding our key, okay? So let's put our keys in here. So our keys from before now are in this table, and we have a value. So now we've replaced it with a tuple. Instead of having to do any sorting, we're just going to iterate through each word individually and check if the key exists in our hash map. And because it's a tuple, we can use it as a key. Now, the reason I'm using a tuple over here is because a list is also not hashable. So because a list is mutable, I will be using a list, and each index in the list I will be able to edit and then converting it to a tuple later on. And so that's why I'm using a tuple representation, but I will be using a list first and then for our key. So I'll be using a tuple for our key, and our values are over here. So now all we have to do is take our values over here and we just output our values like this. So these values are one group, these values are another group, and these values, well, this value over here is one group. And so that's our program. That's how we're going to solve it. And like I said, the time complexity is much better. Okay, so let's go ahead and try code this up. So I'm going to create a function called Group Anagrams, and I will take in our strings, and this will be of a list. So for now, I'm just going to return true, and I will create a main function, and in here I will call our Group Anagram. So I will print this result, and I will put our array over here. So that's our main function, and I will just call our main function like this. And let me put this on one line so it looks a bit better. Okay, and let's run this to make sure we're getting an output. Okay, cool, this is nice. So actually for this, let's go ahead and just call this by having sort. So we're just going to do the sorting approach first, right? So it's simple in the way that all you have to do is we'll have remember we had our hash map, so we'll have our hash map. So I'm gonna import default dictionary. So it's basically so I don't have to initialize every time, I can just add to our dictionary. And what I can do is I'll say, so anagram map equals default dict of our list, right? Because we want a list for each of the sorted strings, right? And so now we'll say for string in strings, and then we just call this strings instead, we'll say, and so for our string we're going to sort it. We want to keep our original string though, so we can store it in our hash map, right? We'll say sorted string, right, is equal to sorted, and we'll take in our input of our string, which we have from over here, right? And we'll say with this sorted string. And so now we have our sorted string, and with our sorted string, what we want to do is we want to now use that as our key. So we'll use our anagram map, and we'll say for our anagram map, the key is now going to be our sorted string. So this is now a list because we use sorted. If we look at sorted, it returns a list. So all we have to do is join it up, and we'll say we'll join our sorted s. And so for our anagram map for the sorted string, so for example, if it's t, it will become 8, AET. We're going to now put an append of, so we're going to take the original word and we're just going to append it, right? So now we're building up our hash map, which has the key of the sorted word and the original word, right? And then all we have to do is we return anagram.map.values, right? And so that should be it. Right, so yes, we're getting eat, t8, tan, nat, and bat. And it's represented like this in dictionary.values. But instead of having it in this format where we have values, it works, right? But we can make it a list to make it the exact type that the problem might want. If it's tuple, you can put tuple instead. And so that's our answer. Now again, so this is, if you want to look at it in code to maybe make more sense of it, this is going to be for each string. So this is going to be our m part in the n log m algorithm, and then this over here is going to be our n log n part of the algorithm. So we'll have m times m log n, and then that's our answer, right? But like I said, we do not want to sort. If we can replace this sorting part with something else, that would be much better. So let me go ahead and just create this function, and we'll just modify it, right? So instead of having sort, what we'll do is we'll have a tuple, right? I'm just gonna call it tuple for now, and then I'll put tuple down here, and instead of having this sort, right, we'll just replace this n log n part by having a mapping. So we'll create a mapping which is equal to, we'll have an empty set of values. We'll have 26 to represent each character in the dictionary, lowercase, right, which I said. And so 0 to 25, basically 0 is going to be A, 25 is going to be Z, and B is going to be 1, C is 2, etc. And now what we have to do is we think, how can we convert the letter into a number like 1 to 25? And so this is pretty simple. Let's go ahead and iterate over each letter first. So for C and S, so what we'll do is we'll say mapping of the existing character which we have here. So if we want it in number format, what we can do is actually use ORD function. So odd. And so odd, it basically returns the Unicode value of whatever we put in. So we can just minus whatever the value of A is, like the character A. So if we know that the value of A is 15, then we know that the value of Z is going to be 25, add 15, which is going to be 40. So whatever this value is will be basically nullifying. Hopefully that makes sense. Okay. And so in our list, what we're going to be doing in our mapping, we're going to be incrementing that index by 1, right? And so now what we can do is for our anagram map, our anagram map is going to now be representing the map in this format where we need to now convert our mapping, which is an array, because remember I said that an array is not hashable, so we'll convert it to a tuple, which is, and then we will append this original string, and then we just return our values at the end. Again, we don't need to have list, but we can, and so we can just put list, and then it looks nicer like this. And yeah, that's the same answer, but the time complexity is much better. There's a similar way I've done this, so instead of using this representation of tuple, I'm using a map, and then I'm incrementing each value. So instead of using a hash map, in a hash map, what I'm doing is I'm using a list to check if it exists. So like indexing and again, like the same thing. But yeah, I hope that made sense and I hope you enjoyed. So yeah, if you have any other questions or if you want to check out some other videos I have, do check out my YouTube channel. And it would be awesome if you subscribe and let me know if you want another question solved and explained. Bye bye.